Hi everyone, and welcome to week 12 of Introduction to Logic. This is going to be a fairly short video as there is only one new predicate logic rule of deduction that we're going to cover today, what's called the quantifier negation rule. Let's go ahead and dive in. Your textbook actually gives 4 different versions of the quantifier negation rule, but only 2 are really necessary, and I've put those 2 on the screen here. The quantifier negation rule has to do with how to handle the negations of quantified statements, something which you may have seen in the section about translations in predicate logic from a couple of weeks ago. I want to talk through these 2 different forms of quantifier negation, talk through why they work, and then we're going to do just a small number of proofs together using the quantifier negation rule. I think you'll see that quantifier negation is pretty easy to understand, pretty easy to apply inside the context of a proof. So this is going to be a fairly short video for you guys, hopefully, which will give you guys some extra time to work on your homework for this week. But let me highlight some things about these rules that you're seeing on the screen in front of you right now. Take this statement here on the right side of the first form. If you have a statement like this, it's not the case that there exists something that's an A. That's what that first statement says, right? We have a tilde here that says it's not the case. So it's the negation of something. We have an existential quantifier. So it's not the case that there exists. And then the predicate here is an A. So it could be something like an apple or an animal. So if there does not exist something that's an A, I want you to think about what this means. This means everything that exists is not an A. So these 2 statements are equivalent to each other, and that's what those 4 dots indicate. So the quantifier negation rule is a rule of replacement. It can apply to an entire line or to a part of a line. But whenever you have a negation either in front of or outside a quantifier, what this amounts to is that you can move the quantifier from outside the quantifier on the left to inside the quantifier on the right, as long as you change the quantifier to the opposite kind of quantifier, from an existential quantifier to a universal quantifier, or from a universal quantifier to an existential quantifier. And I want you to think about it going both ways. On the left, on this first row, this first form of quantifier negation, on the left, we've got this statement. There, for everything that exists, there's a universal quantifier. For all x, that x is not an A. In other words, everything in the universe is not an A. What that means is on the right, there does not exist anything that's an A. So I think you can see that these 2 statements are equivalent to each other in that top row. And let's do the same thing with the opposite quantifiers. And I think you'll see that this holds up for both quantifiers. Let's start over here on the right. If it's not the case that everything in the universe is an A on the right here, that means over here on the left, there has to exist something that is not an A. And vice versa. If there exists something that's not an A, that means it's not the case that everything in the universe is an A. So again, this equivalence holds in both directions. And that's the quantifier negation rule. Functionally, you can take this negation, move it outside the quantifier as long as you change the quantifier to the opposite quantifier, from an existential quantifier to a universal quantifier, or vice versa, from a universal quantifier to an existential quantifier. Okay, so this is a pretty easy rule to understand. Let's go ahead and apply this rule inside the context of a deduction proof. So here I've got 2 premises. The first premise says, if it's the case that everything is an A, the main operator here, of course, is this horseshoe. So if everything is an A, then there exists something that's a B. Premise 2 says, for all x, that x is not a B. In other words, everything in the universe is not a B. And the conclusion we're trying to conclude is that there exists something that's not an A. Okay, let's go ahead and dive in. What I see right off the bat is that if I applied quantifier negation to line number 2, I would get this. So again, just to reiterate how this rule works, I'm going to take this negation, move it outside the quantifier, and change the quantifier from a universal quantifier to an existential quantifier. So that means the negation is going to come out front. We're going to have an existential quantifier instead of a universal quantifier, and that negation is gone. So we're just going to have Bx. And that's going to be quantifier negation of line number 2. And that's really handy because that gives us the negation of this consequent, or excuse me, the negation of the consequent of this conditional in line 1. And hopefully, again, this should be review at this point, but this will let you do a modus tollens step. So if you have the negation of that consequent, we know that the negation of the antecedent has to be true. So on line 4, from lines 1 and 3, we know that this antecedent has to be false. So it's not the case that for all x, a x. And that's going to come from line 1 and line 3 by modus tollens. Okay, now take a look at the conclusion. The conclusion is an existential statement. There exists some X that's not an A. But on line 4, we have it's not the case that everything is an A. And according to the quantifier negation rule that we just looked at, those two statements are equivalent to each other. And think about this. Line number 4 says it's not the case that everything is an A. That means there has to exist something that is not an A, and that is the quantifier negation rule. So on line 5, I can apply the quantifier negation rule here on line 4. And I'm going to use a slightly different color here just so you can see what's going on. I'm going to take this negation, this tilde, move it inside the quantifier to the opposite side of the quantifier. But I have to change the quantifier to an existential quantifier from a universal quantifier. So give me a second to erase that little arrow. There we go. So I'm going to have not a universal quantifier, but an existential quantifier. That negation is now inside the quantifier on the right instead of outside on the left, and the rest of the statement is just the same, AX. And that's going to follow from line 4 by quantifier negation, QN. And we're done. That is the conclusion. So these proofs that you're going to encounter in section 8.3 of your textbook are going to be fairly straightforward. There's some longer ones by the end of the homework, but whenever you see a negation either inside a quantifier or outside a quantifier, you want to have quantifier negation in mind, because this is a handy technique that lets you take a negation and move it inside a quantifier, or even inside a chain of quantifiers, or outside the quantifiers. If you have a negation somewhere inside the quantifier, you might have to apply some other rules, some of the propositional logic rules you already know. But generally, if you see that if you need something that you don't have the right quantifier for, universal quantifier and existential quantifier, be on the lookout for a quantifier negation step, because it'll let you shift the negations around, and it'll also let you move between one quantifier and another as long as you move those negations around. So let's do another example. I just have a few examples for you. This, like I said, this is going to be a pretty short video because quantifier negation is a fairly easy rule to understand. Okay, I've got two premises here. Premise 1 is an either or statement. It says either there exists something that's not an A, or there exists something that's not a B. Line 2 says everything is a B for all X, BX. And the conclusion we're trying to prove is this. It's not the case that everything is an A. It's not the case that for all X, that X is an A, or it's not the case that everything is an A. Let's go ahead and dive in. We're going to add a new line, line 3. Also, in principle, you could use indirect proof or conditional proof as needed. But in section 8.3, your textbook says to avoid using conditional proof and indirect proof. And I want you to avoid using indirect proof. I could use indirect proof here, but I'm not going to do that because your textbook tells you at this point not to use conditional proof or indirect proof for predicate logic just yet until next week. So what I see, there's nothing I can do right off the bat. But I noticed that if I introduce a double negation in front of line 2 to get this, let me just cite it real quick. That's double negation of line 2. What I noticed from there is that if I apply quantifier negation and move one of these negations inside this quantifier, changing that quantifier to an existential quantifier, I will end up with this statement. It's not the case that there exists an X, not BX. Having moved one of these negations, I'm going to use a different color here so you can see what I just did. I'm going to take one of these negations, move it inside the quantifier. Actually, technically, strictly speaking, let me correct this here. Strictly speaking, it would be this negation since it's the one right next to the quantifier. I move that negation inside the quantifier, and I change the quantifier from a universal quantifier to an existential quantifier. That gives me the negation of one of these disjuncts up here in line 1. So I'm starting to set up a disjunctive syllogism step. But the key thing here was that I needed to recognize that I had to do this double negation step before I could do a quantifier negation step. So that's something to be on the lookout for too, is sometimes you'll have to apply some of the propositional logic deduction rules that you already know in order to be able to apply a rule like quantifier negation. So if you didn't see that double negation step on line 3, you really would have been stuck. But if you saw that, hopefully you see how we went from line 3 to line 4, moving one of those negations inside the quantifier, and then I have to change the quantifier from a universal to an existential, or it would have been vice versa if it had been the other way around. So let me cite this now. This is going to be quantifier negation, QN, from line 3. You only have to cite one rule when you're citing quantifier negation, or one line when you're citing quantifier negation. Okay, now, since I'm setting up a disjunctive syllogism step, I need to apply commutativity to reverse the order of the disjunction in line 1 so that the term that I have the negation of is on the left. So let's do a quick commutativity step. I know it's one of these tedious steps, but we got to do it. There exists some x, not bx. That's going to be on the left now. Or there exists some x such that that x is not an a. And that's going to be line 1 commutativity. Okay. Now, happily, line 4 gave us the negation of one of these two disjuncts. So using the disjunctive syllogism rule, we know that the disjunct on the right now has to be true. So there exists some x that is not an a. In other words, this term right here, the right side of that disjunction. And that's going to follow from line 4 and line 5 by disjunctive syllogism, ds. Now we're really close to the conclusion. I want you to always keep looking at the conclusion because that will light the way for you. The conclusion is not everything is an A, and it's not the case that everything is an A. Well, line 6 is there exists something that's not an A. That says the same thing as not everything is an A, and that is the quantifier negation rule. So if we then apply quantifier negation to line 6, and again, I'm just going to use a different color arrow here so you can see what's going on. What I'm going to do now, I'm going to take this negation inside the quantifier on line 6, and I'm going to move it outside the quantifier and change that quantifier from an existential quantifier to a universal quantifier. Okay, so let's do that. Just got to pull up the right color pen here. There we go. Okay, so we're going to take this negation, move it outside the quantifier, change that quantifier to a universal quantifier, and then we're just going to have the rest of the statement as it was, just AX. And that is the conclusion. And we got that from line 6 by quantifier negation, and we're done. A fairly straightforward proof. But again here, the key thing to notice is that you might have to do some setup before you can apply quantifier negation. So be on the lookout for that in the homework exercises for this week. Okay, let's do just a couple more. Like I said, it's going to be a very short video because there's not much to master here with quantifier negation. So in this argument, we're given two premises. The first premise is an either-or statement. There exists something that's an A, or there exists something that is both a B and a C. The second premise says it's not the case that there exists something that's a B. In other words, there does not exist something that's a B. And the conclusion is just this: there exists something that is an A. So let's see what we can do here. On line 3, what I see is that there's not much you can do with line 2. You can't do an instantiation step because the main operator is not this quantifier. It's bound by this negation out in front. So probably in order to use line number 2, I'm going to have to apply quantifier negation and get that negation inside the quantifier, changing that quantifier from an existential statement to a existential quantifier to a universal quantifier. So let's do that right off the bat. We're going to take this negation, move it inside the quantifier, change the quantifier to a universal quantifier. So we have for all x, it's not the case that bx, like so. And that's going to follow from line 2 by quantifier negation. Okay. Okay, now what I see in the premises, I'm going to use a different color so you can see what's going on here. I see that the conclusion just is the other, the left-hand disjunct of the disjunction in line 1, which tells me that what I'm really looking for is the negation of this term on the right. And if I could get that, then I could do disjunctive syllogism and I would be done. So let me just create a little scratch work for myself here. What I see is that what I'm really looking for is this. I'm looking for, it's not the case that there exists some x, bx, and cx, which of course itself by quantifier negation is equivalent to this. For all x, it's not the case that bx and cx. And what I notice is that looks a lot like De Morgan's rule. I'm still going to leave this universal quantifier alone. I'm working backwards now from bottom to top. I see that that's equivalent to for all x, not bx or not cx. So that's what I'm really looking for. Once I get something that looks like that, I can apply the rules that I just shown on the right and we'll be done. I'm going to see if I can squeeze this in on one screen without having to erase so you can see what I'm doing here. Okay, so line 3 is a universal statement, and which means we can apply universal instantiation to it. We can instantiate that with a variable or with a constant, but we know we're on the lookout here for another universal statement in the bottom right of the screen. You see that we're really looking for a universal statement. So which means after we instantiate line 3, we're going to have to apply universal generalization in order to get that universal statement that you see on the bottom right part of the screen that I've highlighted with that yellow line. So given that I can instantiate line 3 with a constant or a variable, here I'm going to choose a variable knowing that I have to apply universal generalization later. It's important to see that. So what I'm going to do, I'm going to instantiate line 3 with a variable. So line 3 says for all x, not bx, I'm going to instantiate with the free variable x. So I'm just going to have not bx on its own line. And that's going to follow from line 3 by universal instantiation, one of the rules that we talked about last week. Okay. Now we said we're looking for a statement like this, for all x, not bx, or not cx. Well, if I could get not bx or not cx on its own line, what I've indicated there on the bottom right part of the screen, then I could apply universal generalization, apply these last couple of rules that I just talked about a moment ago, and we'd be done. Well, I have not bx, so I can use addition to add not cx onto that, like so. So that's line 4 by addition. And that gives me the form of what you see inside that universal quantifier in the bottom right part of your screen. Now I can apply my universal generalization rule. So I'm going to take this statement number 5 that contains the free variable x, introduce the universal quantifier, and I'll end up with a statement like this. For all x, not bx, or not cx. And that's line 5 by universal generalization, UG. And now we're almost done. We said that once we did that, we could apply De Morgan's rule and we'd get a statement like this. For all x, we're going to apply De Morgan's rule on this parenthetical expression bound by the universal quantifier on line 6. We're going to get it's not the case that bx and cx. And that's going to be line 6 by De Morgan's rule. Okay, we're almost done. We said that the whole reason for doing that was that if we applied quantifier negation at this step, we would take this negation that's inside the universal quantifier in line 7, move it outside the universal quantifier, change the quantifier to an existential quantifier, and that would give us the negation of this statement of the negation of the right side disjunct that you see in line 1. So let's do that. We're going to take, I'll use a different color here to highlight what's going on. I'm going to take this negation inside the universal quantifier, move it outside, and change that quantifier from a universal quantifier to an existential quantifier using the quantifier negation rule. So let's do that real quick. This negation is coming outside, changing the universal quantifier to an existential quantifier, and everything else will be the same. So we're just going to have bx and cx. That's going to be line 7 by quantifier negation, the new rule for today. Okay, we're almost done. We said that that's going to give us the negation of the right-hand disjunct in line 1. But in order to be able to use disjunctive syllogism, we need to apply commutativity on line 1. So the right-hand disjunct is now on the left-hand side. So on line 9, let's apply commutativity to line 1. We're going to have there exists some x. That's a b and a c, bx and cx, or there exists some x that is an a. And that's going to be commutativity line 1. There we go. I'll squeeze it in there. Okay, we said we were doing that so we can do disjunctive syllogism, and that's going to give us now the right-hand disjunct on line 9. So there exists something that's an A. And that is the conclusion that we were looking for. So we're done. All we need to do is cite this, and this comes from line 8 and line 9 by disjunctive syllogism, and we are done. So I'm going to indicate the key steps here, where the new rule occurs. So I'll highlight this in blue for you here. So we applied quantifier negation right here on line 3. We couldn't instantiate line 2 because the main operator, so to speak, of line 2 is not that existential quantifier. It's a negation. The tilde is out in front of that existential quantifier. So it's not until we apply quantifier negation that we can do this universal instantiation step on line 4. right? Just remember that with the instantiation rules, you can't apply the instantiation rules to a part of an entire line. And on line 2, you don't have an existential statement, you have a negation of an existential statement. So you can't apply an instantiation rule. We also applied quantifier negation right here because we recognized that once we had this universal statement on line 7, we were going to need to get the negation of this existential statement that makes up the right-hand disjunct of line 1. So that's why we had to apply quantifier negation there. So again, pretty straightforward proof, and be on the lookout for this. Whenever you need to change quantifiers, or when you see a negation out in front of a quantifier, or a negation immediately inside a quantifier, you should start to think quantifier negation. Okay, let's do one more example, and I will give you the rest of your week back to do some practice exercises using the quantifier negation rule. Okay, so on line 1, we've got an if-then statement, a conditional. The antecedent is there exists some x that is not an a. So if there exists something that's not an a, then for all x, bx implies cx. In other words, all b's are c's. Everything that's a b is a c. Hopefully that way of talking about existential statements and universal statements is becoming habitual now that you've done translations in section 8.1 and done some sample proofs in section 8.2 using the instantiation and generalization rules. So in line number 2, we have it's not the case that for all x, x is an a or x is a c. So it's not the case that everything is an a or everything is a c. And the conclusion is just this. It's not the case that for all x, bx. In other words, it's not the case that everything is a b. Let's dive in. I don't know how many lines this one's going to take, but I suspect it's not going to be too much. So line 2, we have the negation of a universal statement. We can't instantiate that because the main operator is not that universal quantifier. It's that tilde out in front. So in order to apply an instantiation rule on line 2, we're going to have to apply quantifier negation, converting that to an existential quantifier. So again, I know I'm being a little pedantic here with these arrows, but I really want you to see what's going on here. On line 2, I'm going to take this tilde, move it immediately inside the quantifier, leaving the rest of the statement alone. I'm going to change the quantifier from a universal quantifier to an existential quantifier. That's the quantifier negation rule. Okay, so let's start there. We're going to apply quantifier negation to line 2. So again, we're going to have an existential quantifier, changing that universal to an existential. We said we were going to move that tilde from outside the quantifier to inside the quantifier, and the rest of the statement is going to be left alone. So that's going to give us, it's not the case that AX or CX. Okay, that's going to be quantifier negation from line 2. Now we have an existential statement. So now we can apply the existential instantiation rule. Now, again, I want to keep reiterating these restrictions on the rules. Whenever you instantiate an existential statement, in other words, whenever you apply the existential instantiation rule, you have to instantiate that with a new constant, a lowercase letter a through w. Now, remember, an existential statement says that there exists one or more particular objects that have the properties that are indicated inside the existential statement. What you're doing when you're instantiating the existential statement is giving that object a name, referring to it by a constant, a through w. And you have to choose a constant that does not appear anywhere else in the proof. Now here we don't have to worry about it. There are no constants in the proof already. But say the lowercase letter a had already appeared in the proof somewhere, we would have to use something like the lowercase letter b or c or d, some new constant that doesn't already exist in the proof. Here we don't have to worry about it, so I'm just going to instantiate it with a lowercase letter a constant a. So I'm going to drop the quantifier, and I'm going to have a statement like this. There does not exist, it's not the case that a is an a or a is, or a is a c. Like so, replacing the x's with the lowercase constant a. And that's going to be existential instantiation of line 3. So you can use any constant you want. You just have to make sure it is a constant that hasn't already been used in the proof somewhere. Okay. So what I see next is that I'm trying to get the antecedent to line 1, to the conditional in line 1, because that'll let me do a modus ponens step. And I see that bx is contained right here inside premise 1. So really to access that, I'm probably going to need to do a modus ponens step. So I'm looking at line 4 thinking, how can I get a statement like this. It's not the case that AA, which matches the form for what's inside that existential quantifier in the antecedent of line 1. So I can apply existential generalization and get that antecedent of line 1. Well, let's see what I can do. Line 4 is the negation of a disjunction, and by De Morgan's rule, I can get this. I can get not AA and not CA. This should be review. This is just De Morgan's rule. So line 4, DM, De Morgan's rule. And I said I was trying to get, it's not the case that AA, it's not the case that the lowercase letter a has the predicate capital letter A. So I can do existential generalization and get the antecedent to this conditional of line 1. So if I just simplify line 5 and get it's not the case that AA, I will have that and I'll be well on my way. So this will be line 5 by simplification. Well, if the lowercase letter a, the object referred to by the lowercase letter a, does not have the property of the predicate capital letter A, that means there exists something that isn't an A. That's what the antecedent of line 1 is. So I'm going to apply existential generalization to line 6, introducing an existential quantifier, replacing that lowercase constant a with the variable x. Right? So line 7 says there exists something that is not an A. And that follows from line 6. So that's line 6 by existential generalization. Okay. We said we were doing that so we could do modus ponens. Let's get that step out of the way. So from line 1 and 7, that gives us the consequent of that conditional in line 1. So for all x, bx implies cx. Okay. That's going to follow from line 1 and line 7 by modus ponens. What I notice next is that the statement in line 8 governs the relationship between bx and cx, right? It says everything that's a b is a c. Well, line 5 says that the lowercase constant a is not a c. So let me start by getting that on its own line. So on line 9, I'm going to apply commutativity to line 5 so I can get not ca on the left. Let's do that right now, get it out of the way. Not ca and not aa. That's going to be commutativity from line 5. Let's simplify and get not CA on its own line. Okay. What I see now is that if I instantiate line 8 using that lowercase constant a, I'll be well on my way to getting the conclusion. So let's go ahead and do that. Because line 8 tells everything that it's a B is a C, and we already know that A is not a C. And I think you can see, hopefully you can see this at this point, but if we instantiate line 8 using the lowercase letter a, we'll be able to do modus tollens, and that will give us not BA. Then we can apply existential generalization to get the conclusion, and we'll be done. So let's do that. We're going to instantiate line 8 using the lowercase constant a. BA implies CA. That's going to follow from line 8 by universal instantiation. Now we said we could do that, so we could apply modus tollens, and that will give us not BA. And that will be from line 10 and 11 by modus tollens. Now here's the key step. Line 12 says that it's not the case that A is a B. It's not the case that the predicate B applies to the object A. We can generalize, and we'll get the form of what I've written over here on the top right part of your screen. So I'm going to squeeze this in. I'm sorry for doing this so small. I thought I'd have enough room here, but I'll squeeze it in. So on line 13, let's apply existential generalization to what we have on line 12. That'll give us there exists some x, not bx. That will follow from line 12 by existential generalization. Sorry to make that so small, but what do you do? Okay, and we said that once we got that, we're really done with this proof. Once we've got that, we can apply quantifier negation. I'll use a different color here to indicate what's going on. I'm going to take this negation from inside the existential quantifier, move it to outside the existential quantifier, changing the quantifier from an existential quantifier to a universal quantifier, and that will match the form of what we're given in the line 1. In the conclusion line. So let's do that. That's going to give us, it's not the case that for all x, the rest of the statement will be exactly the same, bx, and that is the conclusion line. And that's going to follow from line 13 by quantifier negation. and we're done. Very simple proof. So I don't have any more proofs for you guys. I think you can see that everything else that you've been doing so far, all the existential generalization rule, all the generalization rules, all the instantiation rules hold exactly as they did. All the propositional logic rules hold exactly as they did. This is just one new rule that we're introducing that governs how to move a negation inside and outside of a quantifier, how to shift between an existential quantifier and a universal quantifier. So just to reiterate, let me go back up to the rules themselves. I'll do just a little cleanup here to make this easy for you guys. There we go. Delete that, delete that. Accidentally got a G there. There we go. Quantifier negation. So there are really two forms of the quantifier negation rule that matter. You need these two. You don't need the other two forms that are given in the textbook. In fact, some textbooks only give you these two. So I'm not going to talk about the other two forms. If you use them, that's fine. That's absolutely correct. But these are the two that you have to have. So it works like this, just to reiterate. If you have the negation of a quantified statement, like you see here on the right side of the first row, the negation of an existential statement, it says that it's not the case that there exists something that's an A. And if there doesn't exist something that's an A, that means everything that exists is not an A. So we've taken this quantifier, moved it from outside the existential quantifier to inside the quantifier, and we've changed the quantifier from an existential quantifier to a universal quantifier. And it works both ways because these are equivalence rules. So likewise, in the top left, if everything is not an A, that means there does not exist anything that's an A, the right side of line 1. And the same thing works with the other quantifiers as well. So if you have a statement like this in the bottom right, the right side of the second row, if it's not the case that everything is an A, I want you to think about this. If it's not the case that everything is an A, that means there has to exist something that is not an A. So that's why this rule works, and obviously vice versa. If there exists something that isn't an A, that means not everything is an A. This matches up exactly with how we use these terms in English, so hopefully this rule is pretty easy to understand. But mechanically speaking here, what's going on is that this quantifier is moving from inside the quantifier to outside the quantifier, or vice versa, as long as you change the quantifier from an existential quantifier to a universal quantifier, or from a universal quantifier to an existential quantifier. Other than that, the rule is really straightforward. I think you can see that the proofs using this rule are pretty straightforward. I hope this is a bit of a respite from the stress of the last couple of weeks about getting up to speed on the syntax of predicate logic and the basic predicate logic rules, the generalization rules, and the instantiation rules. As always, let me know if you have any questions or concerns. Try to get your homework to me by 11:59 p.m. on Sunday night. Otherwise, I hope you have a great week.